Welcome. In this lecture, we're going to go through two kind of special versions of the existential quantifier. So the first one that I want to go through is this one. So this one here. So what this means is, this means that there exists a unique. So there exists a unique, or another way to think about it is that there exists exactly one. There is exactly one. Okay, so, or there is exactly one. And this is actually one of these lessons actually already to kind of talk about. So sometimes people say, there is a such and such, but they don't say whether you mean unique or not. And that's actually very important in the mathematical context. You want to be as precise as possible. The statement you're making should only have one interpretation or one meaning. So if you mean that there's exactly one, you should say exactly one, or there exists a unique. If you if there might be more than one, then it's okay to just say there exists or there is. So how do we prove this? So to prove, okay, so to prove, this would be there exists a unique statement. Okay, so this one, it's going to start out similar, right? Because you first have to show the existence part. So you state an example. And then you need to show the example works. i.e. that it satisfies all desired properties, i.e. satisfies all desired properties. Okay, and then you show that, and there's actually more than one way to do what I'm going to say, which is to show that any example satisfying the desired property. So show any example satisfying the desired properties the desired properties has to be your example of one. Okay, so is your original example, like the one that you came up with in step one. Okay. Okay. So this is the there exists unique. The exclamation point means that there's precisely one. So there's just an added step in there, which is that you need to show that any other example would have to be your original one, because you can't have more than one. So you need to do that. Okay, so the other one that I want to show you is this. So this is going to be very common. To draw a line through something it basically means no, so there exists no. Okay, so this means there exists no. Okay, so proving A. So proving A. Oh, I wanted to do this. Oh no, I had this idea in my mind and then I forgot. Okay, so I was going to do this orange because orange is similar to red. So proving okay, so proving A, there exists no statement Okay? Is exactly the same as disproving, is exactly the same as disproving, as disproving a there exists statement. So a there exists statement, like we talked about before. Okay? I.e., one usually uses a proof by contradiction. So i.e., one usually uses a proof by contradiction. Okay, so in this circumstance, right, you're actually proving that there is no, right, so there exists no means, it's the opposite of there existing something. You're saying that there is none of this. So it's exactly the same as disproving a there exists statement. A lot of times people do this by a proof by contradiction. Suppose for the sake of contradiction, there exists an injured k such that n equals 2k. Then write n as 2k, and then blah, 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 and the next thing you know, you have a contradiction. Okay, thus, there could not have been one. So that's kind of the way to do something like this. Okay, so I hope that was helpful, made some sense, and I will see you in the next lecture.